Good day, my highly esteemed viewers. You're welcome back to my channel. As you already know, my name still remains Israel. Those of you that have not been subscribing to this channel, please kindly do. And if you have been subscribing, do well to share it. Now, we are returning back to our periodic table. Remember, we are taking it in sequence. So, in our last discussion, we talked about division of periodic table into groups and period. Today, we are going to have a look at what lies between group 2 and group 3 in the periodic table, between group 2 and 3. Now, in between group 2 and 3, we have what is called transition elements. The transition elements, they start from the first transition series or meters or elements. They start from 21 and ends at number 30. So the first one is scandium, while the last one, which is 21, and the last one is zinc, which is 30 by their atomic number. Now, all these elements that stand between, that is between 21 to 30, they are known as transition elements or meters. Transition elements or metal. Now, what is the definition of transition element? Transition elements are those elements that have their d orbital partially filled or incompletely filled. Both of them means the same thing. They are those elements that have their d orbital partially filled. They have their d orbital partially filled, and because of that, the presence of the d orbital in their structure gave them a special property. Some special properties. Actually, there are about 5 properties that are peculiar to them. We know that they are metals also, or metals. We know that they are metals. However, because of the presence of d orbital, it now gave them additional properties which is quite different from the properties of metals that exist in the S and B block elements. S and B block elements, they ends at number 20. But this one have additional properties. So when you are asked the properties of transition elements or transition metal, you don't need to go back to those S and P block elements. Like they are sonorous, they have high melting point and boiling point, they are malleable, and they are ductile. Those are for all of them. The transition metals also have that property. But in addition, because of the presence of partial of d orbital in them, they now have certain properties, which are about 5. So we now go into the properties of transition metal or transition element. You have the first one, they have variable, let me just write the heading, properties. You have one, they have variable oxidation state. You have 2, they act as catalyst. They act as catalyst. You have 3, they are paramagnetic. Paramagnetic. You have 4, they form complex ions. Form complex ions. Then the last one, they form colored ions. So these are the peculiar properties of transition element, not the one for S and P that I just listed before for you before. Those ones are for all of them. When they say state the properties, they are indirectly telling you the one that have d orbital. It is the presence of d orbital that confer these properties on them. Now let us take them in turns. The first one, they have variable oxidation state. This means they don't have just one oxidation number. Like the, remember we are dealing with metals here, not metal like nitrogen that have 3 and 5. No, those are not metals of the S and P. In this case, we are talking about metal. If you look at if you look at the metals of the S and P, they have one oxidation number. Like sodium, just 1 plus 1. Magnesium plus 2 or 2 plus, whichever. So those one have just one oxidation number or state. But in this case, many of them have variable oxidation number. For example, let's say iron. That's the common one they normally use. Iron has +2. You have Fe. You have 2+. You can also have Fe 3+. So you see it. They have more than one. Then for copper, you have Cu+. You also have Cu2+, and so on and so forth. Remember, these are the ones that are really stable form of it. So you have this one. They have variable that they have more than one oxidation number. That's the meaning of variable oxidation state. So we have treated this. Then they act as catalyst. There are many of them that act as catalyst. You have vanadium. Vanadium acts as catalyst. You have vanadium catalyst. Iron can also act as catalyst. So they act as catalyst because they form unstable intermediate. You see it, unstable intermediate, that is which easily decompose into products. They are very, very good at acting as catalyst. Then you have their paramagnetic. Their paramagnetic means they can be attracted to a magnetic field. If they are diamagnetic, they have paired electrons. So this one have unpaired electron. So they are paramagnetic, making them to be attracted to a magnetic field. When we are treating it, we will not treat the complexity, because there are some things when we say they are all these properties we are talking about, there are some of them actually that does not exhibit it. However, like zinc does not exhibit many of these properties, but they also have a particular property that make them fit into this group. So you have, they form complex ion. You see, a complex ion contains a central atom attached to other groups, which we call ligands. For example, you have zinc, ZnOH 4 2-. You see it. This is zinc. This is a complex ion. You have central atom like this. This is the structure actually. ZnOH OH 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 2-. So this is a complex, this is the central atom. These are called ligands. We may have talked about this in our previous video, but remember, it was not as a topic under periodic table. It should have been answering questions when I was assisting many of you when we were preparing for your WAEC and JAM and NECO too. So this is how it is. This is the complex ions. That's for this. Then they form colored ions. The transition elements usually form colored ions. For example, we can use these two. Ion 2 is green in color, while ion 3 is reddish brown. So those are colored ions. The same thing with copper. Copper 1 is colorless, but copper 2 is blue in color. So those are the that's the definition of transition metals, and those are also the properties. So let me just go over them again. Like I said, transition elements or metals are metals that have their d orbital partially filled. There is, because the presence of that d orbital, which is partially filled, because the presence of that d orbital now confers certain properties on them. These are the properties. You have variable oxidation state, that they have more than one oxidation number. For example, you have ion 2 and ion 3, copper 1, copper 2. Then they act as catalysts. They act as catalysts by forming unstable intermediate, which easily decompose into product. I told you have vanadium, have iron, and there are so many other ones. Then they are paramagnetic, meaning they have unpaired electrons, which can be attracted to a magnetic field. Then you have they form complex ions. Complex ions contain a central atom attached to other elements called ligands. They are a group of charged species. So you have they form complex colored ions. Colored ions, you have different colors. The ions are not colorless. You have ion 2 as green, ion 3 as reddish brown or brown. It's actually reddish brown, rust. They have copper 1, you have copper 2. They can even have one color, so long as it's colored. It's a transition metal. Thank you, viewers, for watching my video. As I always tell you, help your friends. Only you cannot just be benefiting. You said they are your friends, they are your friends. How do you show that they are your friends? By sharing all these good things so that they also benefit. God bless you. Shalom.